Welcome back to Azure Services Deep Dive from Data Analytics Actuary. In this series, we've moved from bare VMs through managed fleets, web platforms, and serverless functions. Today, we cover the most powerful and most complex compute service on Azure, Azure Kubernetes Service, the managed container orchestration platform that powers cloud-native architectures at any scale. Container orchestration represents a fundamental shift in how software is packaged and deployed on Azure. Rather than deploying applications to virtual machines or managed platforms, you package your code into container images and let Kubernetes decide where and how to run them. Azure Kubernetes Service sits at the heart of Azure's container story, integrating tightly with Azure Container Registry, Azure Monitor, Microsoft Entra ID, and Azure Networking. For data teams, AKS is the substrate for machine learning platforms, distributed data pipelines, and microservices that need fine-grained, workload-level resource control. AKS lives in Azure's containers category, distinct from the general compute category. The distinction reflects the architecture shift. With VMs and app service, the unit of deployment is an application. With containers, the unit of deployment is a pod, one or more containers that share network and storage resources. Kubernetes is the orchestration layer that manages thousands of pods across a cluster of nodes, handling scheduling, health checking, self-healing, and resource allocation automatically. AKS manages the control plane for you, so you focus on running workloads, not maintaining Kubernetes itself. Azure Kubernetes Service, a fully managed Kubernetes service that handles provisioning, upgrading, and scaling of the control plane, so your teams can focus on deploying containerized applications rather than managing cluster infrastructure. You provision worker node pools, define your workloads as Kubernetes manifests or Helm charts, and AKS handles the rest: API server availability, ECT backups, control plane upgrades, and node health monitoring. Here's the architecture of an AKS cluster. The control plane, the Kubernetes API server, scheduler, and ECT is fully managed by Azure at no additional charge. You provision one or more node pools, groups of Azure VMs that run your workload pods. Node pools can have different VM sizes: general-purpose D-series for web workloads, GPU-enabled NC-series for machine learning inference. The cluster autoscaler monitors pending pods and adds or removes nodes automatically. Azure CNI networking places pods directly in your virtual network, giving each pod its own IP address and full VNet routing. The Azure Load Balancer or Application Gateway routes external traffic to the right services. And managed identity integration means your pods can access Key Vault, storage, and other Azure services without hard-coded credentials. Let's explore the problems AKS solves at scale. First, microservices architectures with independent deployment pipelines. A claims processing platform might have separate services for intake, validation, pricing, and payment, each deployed independently on its own schedule, each scaled based on its own load. AKS lets each service own its runtime and scale individually, with Kubernetes namespaces providing logical isolation. Second, machine learning model serving. GPU node pools in AKS host TensorFlow and PyTorch model servers that need elastic capacity during peak inference windows. Kubernetes horizontal pod autoscaler adjusts replica counts based on GPU utilization or request queue depth. Third, actuarial batch jobs with Kubernetes cron jobs. Monthly or quarterly model runs execute as scheduled Kubernetes jobs, spinning up compute on demand and terminating cleanly on completion, with full audit trails in pod logs. Fourth, multi-tenant SaaS platforms. Namespace isolation and Kubernetes RBAC allow multiple clients to share a single cluster with strong workload separation and per-tenant resource quotas. AKS integrates deeply with the Azure platform. Azure Container Registry stores and distributes your container images with integrated authentication, no registry credentials to manage. Azure Monitor with Container Insights gives you live pod metrics, node health, logs, and alerts across your entire cluster. Azure Policy enforces governance rules, blocking privileged containers, requiring resource limits, enforcing image signing, automatically across every workload. Microsoft Entra ID provides cluster RBAC tied to Azure AD groups, so access control is managed centrally. Azure Key Vault secrets are mounted directly into pods via the Secret Store CSI driver, keeping credentials out of Kubernetes manifests. And Azure CNI places pods in your virtual network for private connectivity to databases, APIs, and on-premises resources. AKS is powerful, but it comes with real complexity. Kubernetes has one of the steepest learning curves in cloud infrastructure. Networking concepts, CNI plugins, ingress controllers, service meshes, network policies require significant expertise to configure correctly. Cluster upgrades require careful planning. Control plane and node pools must be upgraded in sequence, and some upgrades require workload restarts. Windows container support in AKS lags behind Linux. Some Kubernetes features and monitoring integrations are Linux only. Control plane logging is not included in the free tier. You'll need a log analytics workspace, which incurs cost. And node auto-provisioning can take 2 to 5 minutes when a sudden spike requires new nodes, potentially causing brief resource starvation. To recap, Azure Kubernetes Service is the right choice when you're building cloud-native applications that need fine-grained, workload-level control, independent scaling, independent deployment, and heterogeneous runtime requirements. For data and actuarial teams, AKS underpins machine learning platforms, distributed batch pipelines, and complex microservices architectures where the flexibility of containers justifies the operational investment. The trade-off is real complexity. AKS rewards teams that invest in Kubernetes expertise. That wraps up our first 5 Azure services. We've gone from bare VMs through elastic scale sets and managed web platforms to serverless functions and full container orchestration. If you found this series useful, please subscribe and hit the notification bell. There are many more Azure services to cover. Next up, we'll be diving into Azure Storage Services, starting with blob storage. I'll see you in the next one.